When thinking about digital privacy self-defense, there are a number of fundamentals to look for that will help you assess the privacy level of a product or service. Was the service created as a privacy alternative? If the service markets itself as a privacy alternative to an existing big tech service, this is always a good start. For example, DuckDuckGo markets itself as a privacy alternative to using Google Search. Given its relative lack of surveillance capability or aspirations, DuckDuckGo largely fulfills on its privacy promise. Although as a US-based company, it doesn't get an A grade due to the Patriot Act. If the online service makes money by acquiring your data for personalized advertising, it cannot, by definition, respect your privacy. Startpage.com launched in 1998 with this promise and became a popular search engine for privacy advocates. It uses Google search results, but acts as an anonymizing proxy in between you and Google. It does make money by selling advertising, but does so purely related to search terms rather than your personal data. Most online services we use are centralized, i.e., they're under ownership of one private corporation which holds all of our data, like Facebook or Amazon, for example. Decentralized services are where there are multiple instances of the software that are not under single ownership and that interoperate. The software could be federated across multiple servers, or the software could be running on your actual device as a distributed app, or DApp as they're known. Decentralized services have privacy baked in because there's no central oversight of your data, and your data may never even leave your own laptop. An alternative to Amazon that runs a decentralized service is OpenBazaar. It runs on your laptop and allows you to buy and sell goods with no central intermediary, otherwise known as a peer-to-peer model. This was the original way Skype worked before Microsoft acquired Skype and routed all communications through its servers, thereby removing its inherent privacy. It's still early days for decentralized services, but do try them where you can. Most of the software that you use is likely to be proprietary, i.e., it's owned by a company, costs money, cannot be legally copied, and gives no access to its source code, how it's written. For example, Microsoft Windows, Microsoft Office, Apple iOS, Photoshop, and most apps on your phone are proprietary. Free and open source software, or FOSS, is software that is not owned by a company. It's free as in money, but also free as in liberty, because it gives you a legal license to use and amend the software as you wish. Effectively, you own it when you download it. And being able to access the source code means that developers and security professionals can check if the software is spying on you or not, i.e., whether it's malware. This is the opposite of the proprietary model of security by obscurity, which requires you to trust that the proprietary software is not spying on you, because you're not allowed to view its actual code. FOSS is developed by communities of developers for their own benefit and for the benefit of others, in the same way that Wikipedia is created by the community and everyone benefits. The Linux and original Android operating systems are examples of free and open source software. Much of the internet runs on free and open source software, such as the Apache web server or WordPress. And there is almost always a FOSS version of popular proprietary software that you might still be using. Oh, and 100% of the world's top 500 supercomputers run on free and open source software, Linux. Does the service use end-to-end encryption? Encryption is the method by which information is converted into secret code that hides the information's true meaning. Without encryption, our communications over the internet can easily be intercepted and read by corporations, governments, and hackers. Here's how encryption works. When Alice and Bob use software that encrypts their messages to each other, the software creates for each of them a public key and a private key pair. Each person's key pair is unique to them. So when Alice sends Bob a message, Alice's software uses Bob's public key to encrypt her message on her laptop before sending it over the internet to Bob. Anyone intercepting this message will be unable to decrypt it, because modern encryption is usually too strong for current computing capabilities to break. When Bob receives Alice's message, his private key is able to unencrypt the message because his private key works with, and is the only key in existence that works with, his public key. Encryption is used whenever a secure connection is required online, such as when you enter a credit card's details on a website, or use a banking app, or use a secure messaging app. Most websites turn on encryption by default with HTTPS. Without encryption, your security and privacy is compromised. Unfortunately, governments around the world have recently been calling for, and in Australia's case legislating for, encryption backdoors. These backdoors basically give the government an extra key that enables them to intercept and read any encrypted communication. Governments claim they need backdoors to prevent crime and terrorism, but most cybersecurity and privacy experts are strongly against such initiatives. Does the service's jurisdiction afford legal protection? The General Data Protection Regulations of 2018 provide data protection to all EU citizens regardless of the jurisdiction the website itself falls under, in effect, forcing all websites to comply with GDPR. This is a welcome position for EU residents, but a controversial position with most non-EU websites. As such, ensuring compliance and enforcement for any wrongdoings on web businesses outside the EU is, at best, challenging. Try to ensure that the jurisdiction stated in the terms and conditions is a country with strong privacy legislation, a legal system that is robust, and has a respectful demeanour towards the EU. Perhaps easier said than done. A key cybersecurity principle which applies to privacy is security by isolation and compartmentalization. Online, this means minimizing your use of multiple services that originate from one provider, as your data is likely to be linked and shared if you do so. For example, using Google's Chrome web browser on a Google Android phone to search google.com for a Google YouTube video that you share with a friend via Google's Gmail is about as bad as it gets for your data privacy.